4-3 unit circle. Recall quadrantal angles, also known as points on axes. Here we have what's called the unit circle, and we assume that the circle has a radius of 1, the unit, 1 unit. So the point right here on the unit circle at 0 degrees or 0 radians is 1, 0. Up here at 90 degrees or pi over 2, that is going to be the point 0, 1. So 0, 1, and then at 180 degrees or pi, we have negative 1, 0. And then at 270 degrees or 3 pi over 2, we have 0, negative 1. We're going to come back to this slide. Let's cut pi into 3 pieces. So we have 1, 2, 3 pieces. That means this is 1 pi over 3, this will be 2 pi over 3, and this is 3 pi over 3, which is pi. Well, when we do that, we have a 60-degree angle. So here's 60 degrees, and we want to know this point right here on the circle. So we need to know how far to go over on the x and how far to go up on the y. Well, we create this 30, 60, 90 right triangle. So this is 60, this is 30, and this is 90 degrees right here. Well, if this is 1 unit long, this really comes from an equilateral triangle. So if you cut an equilateral triangle in half, you get a 30, 60, 90. That means this side is 1/2, and then we need the height of this circle. Well, we have h squared plus 1/4, that's 1/2 squared, is equal to 1 squared, or 1. So h squared is equal to 3/4, because we have 4/4 minus 1/4. So the height is equal to the square root of 3 over 2. So this is square root of 3 over 2, and this is 1/2. So the point for 60 degrees is 1/2 square root of 3 over 2. Well, this is a right triangle, so we know that the sine is the opposite side over the hypotenuse, which will be square root of 3 over 2 over 1. So the sine of this angle, the sine of 60 degrees, is actually square root of 3 over 2. It's the point on the unit circle. Cosine is adjacent over hypotenuse, and since the hypotenuse is 1, the cosine is 1/2. So the points on the unit circle are the same as the cosine of the angle, x is cosine, and the y-coordinate is the sine of the angle. So now if we go back to this slide here, the cosine of 0 degrees is equal to 1, and you could say the cosine of 0 radians. And the sine of pi over 2 is equal to 1. That would be the y-coordinate of the point on the unit circle at pi over 2. Well, now this is that's the point for 60 degrees, or pi over 3. And so the point for 120, or 2 pi over 3, is going to be negative 1/2 positive square root of 3 over 2. For 4 pi over 3, both are going to be negative. So we have negative 1/2 negative square root of 3 over 2. And then this one over here, it's the x that's going to be positive, and the y is going to be negative. We have 1/2 negative square root of 3 over 2 for the point of 300 degrees, or 5 pi over 3. So if we said, what is the cosine of 5 pi over 3, that's the x-coordinate, the answer is 1/2. Well, let's cut pi into 4 pieces, 1, 2, 3, 4. So we have 1/4, 2/4, 2 pi over 4 up here at the top, that's the same as pi over 2. So it's more of a pi over 2 than it is a pi over 4. So we have 1, 2, 3, 4 pieces. Here's the third pi over 4. Then this would be pi, and we could keep going. So this would be the 5 pi. 6 pi over 4 is 3 pi over 2, and here we have 7 pi over 4. Then 8 pi over 4, and we'd be back to 2 pi, or back to 0. Well, we have a 45, 45, 90 right triangle. So this is 45, and this is 45. And this triangle comes from a square. So if we can make a square, cut that in half, this would be, this is 1, and this is a side, and this is a side. So we'd have side squared plus side squared equals 1, which is 2 sides squared. And so side squared would be 1/2. We would square root that, which is 1 over square root of 2. And if we rationalize, it's square root of 2 over 2. So this length is square root of 2 over 2, and this length is square root of 2 over 2. So if we were to pull that onto the unit circle, that means the point on the unit circle is square root of 2 over 2, square root of 2 over 2. And the reason we care about this is now we know both sine and cosine of pi over 4, or 45 degrees, is square root of 2 over 2. So now over here at 135, it's going to be negative square root of 2 over 2, square root of 2 over 2, because the x is negative and the y is positive. So at 225, or 5 pi over 4, they're both going to be negative. So the cosine of 5 pi over 4 is negative square root of 2 over 2. And then here, the x is positive and the y is negative. If we cut pi into 6 pieces, 1, 2, 3, 4, 5, 6 pieces, then we have 1 pi over 6, 2 pi over 6, that's the pi over 3, 3 pi over 6, that's the pi over 2, and 4 pi over 6 is the same as 2 pi over 3. So here's a true pi over 6, 5 pi over 6, 6, 7, 8, 9, 10, there's 11 pi over 6, and then back to 2 pi. Well, this now is a 30, 60, 90 right triangle. So this, instead of being 1/2 square root of 3 over 2, is square root of 3 over 2, 1/2. So we have square root of 3 over 2, 1/2. This is going to be negative square root of 3 over 2, positive 1/2. These are both going to be negative. Negative square root of 3 over 2, negative 1/2. And then this one is going to be square root of 3 over 2, negative 1/2. And that's the points on the unit circle at the pi over 6's. The way I memorize this is I always try to find the 1/2. Here we have a little demonstration of the arc angle. Here's 60 degrees, or roughly, and here's the y coordinate and the x coordinate. Notice that on a 60-degree angle, or pi over 3, the x is going to be 1/2. So I visualize this 60-degree angle, and x is the 1/2. Now with a 30-degree angle, I try to visualize the y as being the 1/2, and the other one just has to be the square root of 3 over 2, which is about 0.87. So over here at 2 pi over 3, I just try to visualize which one would the half be. In this case, the negative half. And it's the x that's the half on 2 pi over 3. Here's another little trick to memorize the values. Imagine your left hand, if you were looking at your own left hand. This is pi over 6, this is pi over 4, and this is pi over 3. So imagine you were trying to find the values of pi over 6. Everything is over 2, so just pull that finger in, and we have square root of 3 over 2. So square root of 3 over 2 is the x, and 1 over 2 is the y. If you want pi over 4, pull that finger in, the middle finger in, and it's square root of 2 over 2, square root of 2 over 2. You have 2 fingers left here and 2 fingers left there, so they're each square root of 2 over 2. And then if you wanted the pi over 3, pull that finger in, that's 1/2, and this is square root of 3 over 2. That's the x, that's the y. So there's a little trick to memorize the values for the 3 big angles in the first quadrant. Use reference angles to find trigonometric values. Find the exact value of sine of 4 pi over 3. So let's find 4 pi over 3. Here's 1/3, 2/3, 3/3, 4/3. So the reference angle for 4 pi over 3 is just pi over 3. And the coordinates here are 1/2 square root of 3 over 2. So the coordinates down here must be negative 1/2, negative square root of 3 over 2. And we're asked to find the sine of that angle. Sine is the y coordinate, so negative square root of 3 over 2. Find the exact value of tangent of 150 degrees. So here's 150 degrees right there. So this is 30 degrees, and we have negative square root of 3 over 2, 1/2, because its reference angle is 30, which is square root of 3 over 2, 1/2. Tangent is opposite over adjacent. So if we have opposite, that's the y coordinate, over adjacent is the x coordinate. And the x is cosine, and the y is sine, so we really need y over x, opposite over adjacent, which is sine of the angle over cosine of the angle. So tangent is the same as sine over cosine. So if we have 1/2 over negative square root of 3 over 2, we can multiply the top and the bottom by 2. Those cancels out the 2's, that cancels out the 2's. We have negative 1 over square root of 3, or negative square root of 3 over 3. Find the exact value of secant of 15 pi over 4. So we need 15 fourths. So we have 1, 2, 3, 4 fourths, 5, 6, 7, 8 fourths, 9, 10, 11, 12. 13, 14, 15. Right there. There's 15 pi over 4. Its reference angle is pi over 4. And this point is positive square root of 2 over 2, negative square root of 2 over 2. And we want the secant. Secant is the reciprocal of cosine. There's cosine right there. There's the value of cosine. So we have 2 over square root of 2. And let's multiply the top and bottom by square root of 2. We get 2 square root of 2 over 2. Those cancel, so the answer is square root of 2. Let secant of theta equal square root of 29 over 5, where sine is negative. So we'll keep that in mind. Sine is negative. Find the exact values of the remaining 5 trigonometric functions of theta. Well, sine is going to be negative. So that's sine. It goes cosine of theta, sine of theta. So we know that y, we're either in quadrant 3 or we have to be in quadrant 4 because that's where sine is negative. Well, secant is the reciprocal of cosine. So the cosine of theta is equal to 5 over square root of 29. So that's going to put us in actually the 4th quadrant, because if x is positive and y is negative, that has to be in the 4th quadrant. So we have some angle right here. There's the angle. And we know that the cosine is 5 over square root of 29. Cosine is adjacent over hypotenuse. So we know that the adjacent side is 5, and we know the hypotenuse is square root of 29. So we have to find this side right here, and then we can answer all of the trig values. So we have 5 squared plus, let's say, y squared, plus y squared is equal to square root of 29 squared is 29. So y squared is equal to, that's 25, that's going to be 4, so y is equal to 2. So y is 2, and we need sine of theta, we need cosine of theta, and we need tangent of theta. Well, the sine is going to be opposite over hypotenuse, which is 2 over square root of 29. Cosine, we know that is 5 over square root of 29. And now tangent is opposite over adjacent, which is 2/5. Well, the reciprocal of sine is cosecant. So cosecant is square root of 29 over 2. Secant of theta is going to be square root of 29 over 5, and then cotangent is going to be 5/2.